Welcome back to our system design series. Today we are going to discuss two fundamental concepts in data design or in database design: normalization versus denormalization. These two techniques represent different ways of structuring data, each with its own strength and ideal use cases. Understanding when to use normalization versus when to use denormalization can help you design efficient and scalable database for your applications. And also, it's quite important when you try to design the database schema in your system design reviews. Let's start first with the normalization. And this is an example of the normalization. Normalization in database involves splitting up data into related tables to ensure that each piece of information is sorted only once. The primary goal of normalization is to reduce redundancy and improve data integrity, making your database more efficient and easier to maintain. The key characteristics of normalization, first we said, we're reducing the redundancy, because by splitting data into separate tables, you eliminate unnecessary duplication, which helps reduce storage cost and prevent data anomalies. Number two, we have data integrity, because normalization ensures that each piece of information is stored only one place, making it easier to keep your data consistent and up to date. I guess if we want to take an example of normalization, like imagine like a customer database or for e-commerce platform, you could have one table for customer table detail like name, email, address, as you can see, and the other one for order, and a separate table for the order, as we said. By doing this, customer details, like by doing this, you avoid basically duplicating customers information for every order they place. Instead, you simply reference the customer details in the order table, which reduces redundancy and ensures that customer information is consistent across all orders. The benefits of this one, we have data consistency, because since each piece of information is stored in a single place, it's easier to keep data consistent. Second thing, we have reduced redundancy, because normalizations helps minimize data duplication, which reduces storage costs and improves data accuracy. The drawbacks of this one, we have some sort of complex queries, because data is split into multiple tables. Queries might become more complex and require multiple joins to retrieve related information. Also, there is some sort of performance overhead, because normalized databases can introduce performance overhead due to the need to join multiple tables, which may slow down data retrieval. Let's start and talk about denormalization. Denormalization is a process of combining data back into fewer tables to improve query performance. This often means introducing redundancy back into your database, allowing for faster reads, and the cost of increased storage can the cost of increased storage and potential data inconsistency, as well. So the characteristics, first, we have improved the query performance, because by combining data into fewer tables, denormalization reduces the need for complex joins, resulting in a faster query performance. Number two, we have redundancy introduced. This is the second thing, because denormalization often involves duplicating information across tables, which increases storage requirements, but allows for faster data retrieval. An example for that, as you can see here, imagine like this customer order detail, or imagine like a blog website where you want to quickly display the latest posts along with the comments. Instead of storing posts and comments in separate tables, which is normalized, you could store latest comments directly with the post in denormalized fashion. As well, we can do this in the customer order. We can just store all the customer data in the order, basically in the order table, so it's be done in a denormalized fashion. The benefits of this one, we have faster reads, because denormalization reduces the needs for joins, resulting in fast data retrieval, which is particularly important for read-heavy applications. Number two, we have simplified queries, because queries become simpler because all data needed is available in a single table, making it easier to work with. Number two, the problem, the drawbacks, we have data redundancy because denormalization introduces data redundancy, um, meaning that same information is stored multiple places. And also there is increased storage because storing duplicate information increases storage requirements, which may not be ideal for applications where storage costs are concerned. Okay, let's try to answer the question about when to use what. So use normalization. Let's make the n better. Use normalization is ideal for scenarios where data integrity and consistencies are the highest priorities. It's perfect for applications that require high data accuracy, such as financial systems or customer databases, where keeping data consistent is a key thing, and eliminating redundancy is really crucial. Number two, we have the denormalization. Denormalization is better suited for applications where query performance is critical and the system needs to handle read-heavy workloads. It's ideal for applications like content management systems, social media feeds, or reporting dashboards where fast data retrieval is quite important than eliminating redundancy. So that's it for this video, and I hope you liked my content. If you like my content, make sure to subscribe and hit the notification bell so you'll never miss any video, and see you in future problems.